grade 12s, welcome back into this series of videos provided by Dubsmet. So we're still finishing off our number patterns revision. We'll now look at the Mpumalanga Trial 2024 question paper. As you can see, they had around 5 questions. Yes, you're gonna look at these questions. So let's look at the first one. We're given a quadratic sequence with terms 6x, 26, 45, and y. They are saying calculate or determine the values of x and y. So let's look at this solution. So we are given 6x 26, 6x 26, then 45 and y, 45 and y. Okay, these are the first few terms. This is a quadratic sequence. They want to find the value of x and y. So like we said in the previous video from that free state trial paper, we said whenever you're given a quadratic sequence and you're given the terms, the first thing, even if you don't know what to do, just find the first difference and the second difference. It's going to help you. Why? Because the second difference, we know it's always going to be the same. So then you get to be able to equate things. So it's important that you master a couple of the few steps to answer any question, like look for patterns or look for procedures and steps that are followed to answer questions. Like I said, quadratic, we do the first difference and the second difference. Okay, let's do that. So if we do that, here we've got 6 minus, we've got x minus 6. We've got 26 minus x. We have 45 minus 26. We have y minus 45. This is what we call the first difference. Now looking for the second difference, which is the difference of the first differences. Okay, so now here we're going to be saying 26 minus x minus that. So 26 minus x minus, you put your bracket, x minus 6. Then it's 45 minus 26, which is, I can simplify that, it's 19, so it's going to be 19 minus that. So 19 minus 26 minus x. Then here we say y minus 45 minus 19. So y minus 45 minus 19. And then this is the second difference. Okay, and we know the second difference is going to be the same. So let's try to simplify this. That simplifies to, in fact, without even simplifying it, we know that we have to equate these. They are equal, right? They are the second differences. So meaning that that will be equal to that, which will be equal to that. Why? Because the second difference is always the same. So we're going to be saying 26. Let's just write a note to say the second difference is always the same or equal. What by the same mean that they're always equal. So that this 26 minus x minus 6 is going to be equal to 19 minus 26 minus x. Got that? But not just that, we also have that these two are going to be equal. But let's just first simplify this one. So we're going to have 26 minus x plus 6 equal to 19 minus 26 plus x. Then we have 26 plus 6, which will be 32. Then minus x, we get a minus 2x. Here we've got a 19 minus a 26, which would be 7. So minus 7 plus x. We now move x to one side. So you're going to have minus 2x. And we transpose that x becomes a minus x. We have a minus 7 on the right hand side. Transpose the 32, it becomes a minus 3x is equal to minus 39. Then we divide both sides by minus 3. We would get 13. So we get that x is equal to 13. So we now have x. We now need to find y, but now we need to equate that to that, right? Because we have equated those two, now we're equating this one to that. Let us do that. So we have 19 minus 26 minus x. So we now have 19 minus 26 minus x equals y minus 45 minus 19. Y minus 45 minus 19. We now need to solve. So we'll have 19 minus 26 plus x equals y minus, so if we say 45 and at 19 we get a minus 64. But now we know what is the value of x. So 19 minus 26 is minus 7. But now we know the value of x. X is 13. So this would be plus 13 is equal to y minus 64. Then to solve for y, we have that minus 7 plus 13. We transpose the 64, it becomes a plus 64. So we're getting 7 is our y value. So what is important here is just understanding the step that we follow, understanding what the definition of or the property of a quadratic sequence. Then 2.2, we have calculate the sum of the series. We are given a series. Let's just write it down. So you know 2.2, the series is 230, 220, 213, 26. So it's a plus. They are missing terms here, and the last term is 2 negative 11. Okay, we want the sum of the series. So we don't know what is this series, right? So we must first check, is it arithmetic or a geometric? Always we check. Let's first check. Let's start with an arithmetic. It would be, just gonna call it arithmetic check, which would be T2 over T1. We want to check if this is equal to T3 over T2. So for arithmetic check, we want to check if T2 minus T1 is equal to T3 minus T2. What about a geometric check? There we'll be checking if T2 over T1 is equal to T3 over T2. Let's start with the arithmetic check. So then we have 213 minus 220. Then we have 206 minus 213. So we're checking if these are equal. So 213 minus that, we'll get minus 220, we're going to get a minus 7. And even here with a minus 7. So these two are equal. So therefore, it is an arithmetic series. If the left hand side was not equal to the right hand side, we're going to move on and check if it is a geometric series. So this means that our D is minus 7, T2 minus T1. Our A is 220. So we want the sum of this series. So we need to look at our Sn formula, which says Sn is equal to n over 2 a plus n minus 1 times d. So we need to find n. What is n? N is the number of terms. So we don't know how many terms are here. Don't say these are 4 terms, because it's T1, that is T2, that is T3. They are missing terms here. So you can't say there are 4 terms here. So this last term, we don't know what is the n for this term. So we must find the n for this term. So we must first find n. So we then find the number of terms, which is n. How do we find number of terms? If you are given that, we know that Tn would be a plus n minus 1 times d. But we know that the last term here is 11. So Tn is 11. A is 220. We want n. D is minus 7. So we want to solve for n. So we have 11, 220 plus minus 7 times n. We're going to get a negative 7n. Minus 1 times minus 7, we get a plus 7. Then we solve for n. So we transpose all the numbers to the left hand side. So we could have 11 minus 220, then minus 7, which gives us a minus 216. We know the last term given it is minus 11. So minus 11, we know a is 220 plus n is unknown, d is minus 7. Expanding out the bracket, minus 7 times n, we get a minus 7n. Minus 1 times minus 7, we get a plus 7. We now move all the numbers to the left hand side, so we have a minus 11. Transpose the 220 becomes a minus 220. Transpose the 7 becomes a minus 7. So we get 238 here, minus 238. To solve for n, divide both sides by minus 7, and we're getting n to be 34. So there are 34 terms, so this is T34. We can now go back to our Sn formula, which we had here. So S, now we want S, 34. So we have 34 over 2. So this should have been 2a. So it would be 2 times 220 plus n minus 1, 34 minus 1 times t, which is minus 7. And then we just punch this in the calculator, and we're getting 3553. And then the next question, they're saying write the series in sigma notation. So we know sigma notation, connect our sigma symbol, and then we have start here, then we have n, and we have tn here. So what is tn? We know that tn would be a, which is 220 plus n minus 1 times d, which is minus 7. In fact, we can just simplify this, then we'll get a minus 7n. 220 plus 7, it's going to be 227. So minus 7n over tn would be minus 7n minus plus 227. We're starting at t1 here, because this is t1. We're starting with t1. And then where are we ending? Our last term, the position is, it's this one. We found this n to be 34. So we are ending at 34. That's how we write this in sigma notation.